I'm Raju Vegesna from Zoho. For those of you not familiar with Zoho, we do online applications. We have about 17 different applications in different categories, primarily productivity and collaboration, and of course we have applications in some business applications as well. But we have about 17 different applications, and one of the challenge we have is, or one of the most requested feature for us is the offline. So we were asked to support offline capabilities for our application, and at one point we were discussing, or we were evaluating different ways of providing offline support. And initially we looked at some options available like Adobe Air and all, but again these are closed systems, so we didn't want to go that route. And then we decided to look at other options. For example, we looked at Firefox, but then Firefox only is for Firefox. So we decided to build one on our own. So Dojo Toolkit was one of the options that we considered, and then we also looked at SQLite, and we thought we'll develop one on our own. And that was when Google released Google Gears. So we decided there's no point doing one on our own, so we'll just implement Google Gears. And there are a couple of things that really attracted us. That is the license. It's really a BSD license, so it's a no-brainer. And the other one is a simple fact that it's done by Google, which means even if we try to do the offline plugin ourselves, we will not get the same distribution as Google gets, so it simply doesn't make sense to do another one. And we are primarily a software company. We do applications. We don't want to get into the infrastructure and try to sell the infrastructure and for the distribution and all. So we want to be an application company, so we want to focus on the applications. So it simply made sense to take Google stuff and just run with it. Though we compete with Google on one side, so on the application side, because we do the same Office suite like a word processor, spreadsheet, presentation, and a bunch of other applications. But this certainly was not a concern, primarily because we love the open culture of Google, and we love the openness of the Google, and that primarily motivated us to just choose Google Gears. And we also looked at the API, and the API looked pretty good. I mean, we initially decided to do it on our own. When we did that, we had some guidelines, and when we looked at the APIs from Google, they pretty much implemented the same stuff. So it was pretty easy for us to just use the Google Gears thing. And we had several applications, but they can be classified into two categories. One are file-centric applications, and the second one is database-centric applications like Zoho CRM, Zoho DB, and all. And file-centric applications include our word processor, our wiki, and few other applications. So we wanted to take one application and then implement it with Google Gears, and then it's easy for us from then on to extend that to other applications. Similarly, we'll pick one database-centric application, most likely CRM eventually, and we'll roll out other applications. So one thing we have standardized is for the offline support is Google Gears. So going forward, you will see most of the Zoho applications available offline through Google Gears. So Zoho Writer is just one beginning. And we took a phased approach. First, we said we will roll out the read-only mode for our word processor. So when someone downloads the documents offline, he'll just be able to read the documents only, and then we thought we'll add the read-write support later. So like that, we have added read-write support. So, and then there is another version phase that's coming that is primarily for syncing and creating documents. And after we decided to do or implement Google Gears, it just took us 1 month to get started and have the first phase working. And for those of you who are not familiar with our implementation, I just want to do a quick demo here. This is our word processor. On the left, you see a series of documents. On the right, you see our editor. This is a phase 2 where you can select how many documents you want to download or you want to make them available offline, and you can simply go offline. And it downloads and it switches to the offline mode directly. Now you can obviously edit the documents I add some content here, save it in the offline mode, and when you go back online, it synchronizes the documents. It will see that there is a conflict between the online version and the offline version. Do you want to rename it? Just say synchronize, and it will basically move on to the online mode. Now here you can go back to the history of this particular document and do a diff between the latest two versions. Just show diff, and it will highlight the changes that were done between these two versions. The whole thing was done, again, primarily on Google Gears, but then you'll notice that in the offline mode, not all functionalities are available. That is primarily because the nature of these online applications. So that's, in fact, that's some of the challenges here with the offline mode. Here you'll notice that even functionalities like spell check is not available offline, primarily because we support spell check in 43 different languages, and everything is done on the server side. It didn't make sense to download the whole dictionary offline and to offer that. Similarly, there are some other functionalities, like we have an equation editor, which uses LaTeX, and it uses C++ at the back end, and it simply doesn't make sense to download the whole code for that and do it offline. So we provide most of the commonly used functionalities in the offline mode, and then we move ahead and just extend that other functionalities in the online mode. So I'm not sure if we'll even offer these advanced functionalities in the offline mode, but again, it depends on the user request. If there are many users demanding it, then we'll obviously get there. Now, in terms of the implementation, we use all the three modules from Google Gears. We use the local server module, obviously the database, and the worker pool as well. Now, the local server module is primarily used to download the static content, like your JavaScript, images, CSS, and all the stuff is used and is downloaded. And the worker pool module is primarily used for database inserts. So the main thread downloads the documents, and the worker pool module basically inserts the documents into the database. So all the documents are inserted into the database, that is the SQLite. And even here, we use the managed resource store and also the resource store. Resource store is primarily used for downloading the images, and the managed resource store is used to download some of the JavaScript files, which could change often. So we used managed resource store for that. And of course, apart from that, we also save the user actions in the database in the offline mode. So whatever you do offline, we save those actions locally in the database, primarily because if there are any errors, we want to make sure that we capture those errors in the offline mode as well. I mean, if it is the online mode, we certainly can see what are the errors things that are going wrong, but in the offline mode, there is no way for us to know that. So that's why we capture that in the database and later sync that and try to fix the issues. And of course, the other bulk DB operations are done in the worker pool as well. Now, apart from the functionality that is available in Google Gears, we had to add our own extensions. For example, how do we know that the user is offline or online? We had to do some simple AJAX calls to just determine whether the user is offline or not. And that's a simple extension that we had to do. Similarly, online-offline synchronization, when a document is offline and if the user makes any changes and when you sync it back online, we need to make sure that we verify the versions and all of that. We simply have a flag there, which basically for each document, which is enabled whenever a document is changed, and based on that we synchronize online. And of course, we have versioning on the online. We use the same engine for determining the changes between these versions. Now, apart from that, we also have an offline error log.db, which essentially is what I talked earlier. That allows us to log all the user actions and take actions accordingly. And so that was rolled out in 2 phases, and later Google rolled out Mobile Gears. And the modifications, there were no modifications to our code for supporting Mobile Gears. That was the best part. In fact, in about a week, we were able to provide offline access to our users on their Windows mobile device. So primarily because there were no modifications to the Mobile Gears. So that was really boon for us. So Google rolled out a mobile Gears, and we announced support immediately. So it was pretty straightforward for us. And It also gives us some better performance, especially on the mobile networks, where you don't have to load the content from the internet, like the images and all. And so it's simply we're able to use the local cache and use those. And it is really a boon, especially on the edge network. There are certainly some challenges while we while we implemented these, especially identifying the network status. And as I said, bringing the rich functionality online. For example, we do pagination and we do thesaurus in 10 different languages. It simply doesn't make sense to download all of the content offline. So that's a challenge. I guess it may not exist for all the applications, but in our case, we do most of the stuff on the server side. It's not a simple database, so we have different things running at the background, so it simply doesn't make sense to download the whole code. So we may not be offering, or may not be able to offer the whole functionality offline. It's not just a Google Gears limitation. I would say it's a common limitation that will exist for any online application trying to replicate its complete functionality offline. And the next challenge is, of course, authentication and encryption. That's a challenge I guess we will have to address. So we'll have to try to replicate some of the authentication and also add some security to the data that is available offline, because the database is saved as a simple file, and ideally, if it is encrypted, that will be a real good use. I mean, the other one will be a local file storage. One common question we get is, now that we have our documents available offline, and our users want to use their Internet Explorer or Finder to find those files because they are available offline. So that's a challenge for us, because we are saving all the data in the database, and it will be good if Google Gears can support a file system for the documents, for something that we do here. In our case, on the server side, we save the documents as files, but in case of offline, we have to save it in the database. So it'll be good, and it'll be interesting to see how that evolves, but we are certainly looking forward to that. So what's next on Gears? There are a few. We are rolling out the next phase in Zoho Writer. That will be out in the next couple of weeks, and then we have record and playback support for our application. So whatever users do in our offline mode, we plan to just repeat that in the offline mode for different purposes. It's going to be useful for other applications, and we are going to roll out more applications on Google Gears. Just today, I got first milestone of a new application or another Zoho application that's going to go offline in about a month or so. So we'll see more applications using Google Gears going forward. That's briefly about our implementation, and I guess we'll take any questions later after Buxfer. Thank you.
Hello. All right. So I'm Ashwin. I'm one of the founders of Buxfer. Buxfer is an online personal finance application, and In this talk, I'm going to talk about why it made sense for us to use Gears for a couple of different reasons. So the talk is going to be organized as thus. I'll first introduce what Buxfer is, what the basic functionality it offers, then discuss secure client-side storage with Gears, and then briefly discuss and show offline functionality using mobile Gears. So Buxfer is basically personal finance for 20-somethings, for college students and young professionals. We do two things for these kinds of people. First is that you can know where your money is going very easily. You can add your bank and credit card statement details, and we can grab those from the bank credit cards automatically nightly and automatically categorize them. So you know automatically and securely how you have been spending your money. The second thing we do is we allow you to track and settle debts between friends, between housemates, when people go on vacations. There are a lot of messy debts between each other. We allow you to track all these debts and then pay each other using Amazon payments through the site. A couple of important features I'd like to point out. We have very powerful analytics. You can set up categorization rules and budgets so that you have to invest time in setting this up only once. The system learns after that. We also have a Firefox extension to sync your bank accounts if we don't officially support your bank. And this way we are able to support almost all banks from, all over the world. You can, as I said, you can pay your friends using Amazon payments. And you can access the app pretty much from everywhere, from Facebook, by sending us SMSs or emails, Twitter. There's a special iPhone version, and so on. So how does Gears come into the picture? Well, the first important reason is that we think auto-sync of your bank accounts is absolutely critical for this kind of an application, because it significantly reduces the amount of effort that you need to put in order to start deriving value. That's basically the number one reason why people don't use Quicken or Microsoft Money, because it just takes way too long to start deriving value. And so the way it happens with Buxfer is the user types in the password, it goes to the Buxfer servers, and then we fetch your data from the bank, and we throw away the password. We don't store it. And the data that we obtain only contains a transaction description, date, and amount. None of this, there are no account numbers, no other sensitive information in those files. But the sensitive stuff is your bank password, because it is, you can use it to find out the account numbers and do other actions. So, people obviously, feel extremely uneasy when we ask them for their bank passwords. And so we provide our users a bunch of options. First of all, we say, well, we don't store your password ever. It's there in the memory for a few milliseconds while we grab your data, and after that, it's gone. Of course, it means that people have to type it every time they want to get the data, which is an annoyance. And so we also, for those who think that we are trustworthy, we say we'll store it in a strongly encrypted manner on our servers. But, that's still no good. So we built a Firefox extension, which records your bank downloading actions. So you can teach this extension how to download a statement and upload it to Buxfer. And then it's going to do that automatically every night without bugging you. So that's one option, but still, some people don't use Firefox. They're not very happy. They don't understand extensions. So that's where Google Gears came in. We use Google Gears to store the password locally on the client's computer and provide it to our applications, to Buxfer, on a one-time basis. We don't store it. And so we basically get the best of both worlds. The user doesn't have to type the password every time, and it's automatically available to us every time the user logs in. So how did we implement? Well, there's no, it's obvious. For every account, we store a bunch of credentials in the local server database in Gears. And then for subsequent syncs, whenever the user logs in or whenever the user wants to manually sync his accounts, we retrieve this pair from the database and send it to the server. So that's obvious. Well, is it secure? Well, it's kind of not. As some people on Consumerist quickly figured out, within a day of our release, because they looked at the SQLite database, and there it was, their bank username and password sitting in clear text. And so not really useful, because most people's local computers are actually much less secure than a company's servers. And so we decided that we must encrypt the password, but we can't encrypt the password at the client's end, because the code is available to any malware or any attacker. And so what we decided to do was establish a shared key encryption, so that in order to decrypt or encrypt the credentials, we would need the password of the user as well as a shared key, which is known only to Buxfer. And so you need to compromise both these parties in order to grab your clear text password and a username for the bank. So I'm going to show you a quick demo of how easy it feels. So this is the site. I'm going to sign in using an account I just created. So I have set up a few things here. Let's add an account. I'll add an account for Washington Mutual. It's a checking account. And now I'm going to synchronize it. So it's going to ask me for my bank passwords. This is where the sensitive stuff comes in. And we provide the user all these three options. Every night, so when the user stores the passwords on our machines, we can sync it every night. Or every time I log in, this is what needs Google Gears, or manually, if the user wants to type it all the time. So let's select Google Gears. Now this time, it's going to store this information into Google Gears. It has identified that there are two accounts at Washington Mutual. I'm going to select which one I want to sync. And now it's actually grabbing data. So there you have the data. The data is there. It's categorized as well. And now let's try to sync it again. So you can see here that we show that authentication information is stored on your computer, and you can delete that data if you want. So if I hit synchronize again, notice that I will not be asked any username or password. It has grabbed that from the local database automatically and sent it to Buxfer. Of course, it did not find any new transactions now because I had just synced it. Okay, back to the next thing, which is offline functionality with mobile Gears. Now that's mobile access is pretty crucial for our app as well, because a lot of the impulsive buying decisions are made when you are away from your computer. And so people need to sometimes figure out how much money you have in your checking accounts, or how much money you have left for a particular budget, and so on. So we provide interfaces for the iPhone, Windows Mobile. And of course, you don't have network connectivity many times. And so what do you do then? We use mobile Gears for that. And we don't support write actions for now, only support read-only access to your transactions. When going offline, the backend generates a set of pages. And these pages are stored in the local server in Gears. And when going offline, the local server is disabled and stuff is brought from the backend. So nothing really difficult going on there. There's an interesting thing that we do to synchronize incrementally. So if you have synced once and you sync after a day, we'll only grab whatever is changed. And so we store the last transaction ID that we downloaded, and then the next time we sync, we only grab the part of the data which happened after that transaction. So let me show a brief demo of Buxfer. So this is the Windows Mobile emulator. This is the online version of this account. You see a bunch of links. You can see, you can connect to accounts. Do not show this warning. And the session timed out. So you can see the analysis, the pie charts that we just established by syncing the accounts. You can dig down and do a lot of operations. It's a completely first-class interface for the site. Then you can decide to go offline. And at that time, we'll provide you an option on what information you want to be made available. So this time, let's select accounts and the analysis charts and decide to go offline. So this is going to just grab a bunch of pages from the backend and instantiate them into the local Gears server. So now it's syncing. It's going to take a while. Nothing interesting going on there, but you'll be able to use this information later on without the network connection being present. I'll come back to it in a moment. We can go with the presentation. And so one of the challenges is some people want us to support write actions, but as Raju had mentioned earlier, it's kind of tricky doing that because essentially you need to port all your backend functionality, or at least a significant part of it, into bring it to the front end. And so unless you have written your code in JavaScript, which is at least right now pretty rare on the backend. It is really hard to do that. And maybe your backend has a bunch of proprietary algorithms. The categorization engine, for example, that we have is reasonably advanced. And it's really hard for us to pull all of that information into the client side. One possibility is, of course, Gears could provide a runtime to execute some kinds of backend code in different languages, PHP, Python, Ruby. A limited one, of course, limited subset. But that would allow some of that code to be brought over to the client and in a reasonable amount of time. Well, that's it, and we'll take any questions that you will have. I'll also invite Raju back to the stage.
Hi, I do have a question.
Yep.
What happens to two-phase authentication with some bank accounts, especially when you want to type in your password and want to identify an image before accessing your accounts, like a two-phase authentication? Once you sign in with your username and password, the second page you have to identify an image so that it gives an extra authorization to access the accounts, right?
I actually completely didn't understand.
Oh, what happens to two-phase authentication?
Two-phase authentication.
Yeah.
Yeah, we handle that as well. So for it's not true. Not all of them use two-phase authentication, but for Bank of America, we actually take care of the second phase as well. So we store the challenge answer sometimes, and sometimes Bank of America just doesn't. Once you've answered it once and it stores the association with a computer, it doesn't ask it again for a long time. So that works. There are some institutions for which our automation just doesn't work. For example, with ING, which has a virtual keyboard, which keeps on changing every single time. So that just doesn't work.
I would like to add something to this. How about the site key authentication? The challenge questions they don't ask every time, but site key they do need every time you to verify it and then you enter your password.
Well, yeah, I mean, in this case, basically the user is trusting Buxfer. That, Buxfer is doing the right thing. The purpose of the site key is to prevent phishing, so that the user can identify, yes, this is the site. In this case, the user has actually, given this, trust-checking thing to Buxfer, so that Buxfer can say, oh, yes, I'm actually getting this information from Bank of America and not somebody else.
So does Buxfer really check, verifies the site key?
No, Buxfer doesn't, but we know that we don't, we access the right kinds of servers and not click on random links that appear in emails.
Because you do need two-factor authentication, or else the actual insurance for the banking, the federal insurance, is not valid. And that's a major problem. So if you want people to use it to access the banking and be insured under that, you have to use two-factor.
So I actually was very interested in also following up on the security side. Very interesting in terms of hearing your description of what you implemented for the banking. If you can talk a little bit about protecting the data when it's at rest. I guess two questions there. One,
protecting the data
at rest when it's on disk.
Yes,
or,
yes.
Or for that matter,
yes, on the client side.
Flash in Flash on the phone.
Right.
I guess question one is the mobile data protected and encrypted when it's sort of in Flash? And then the second question is, what are your thoughts with regard to implementing encryption in general using the Gears infrastructure?
Well, so the mobile stuff, when you store locally, is not encrypted. And again, part of the reason is that, as I mentioned, the transaction information by itself is not financially sensitive. Because for a mobile device, it can be, because the mobile device encodes your identity as well. But in our case, on the back ends, it's not, because we associate it only with an email address, which could be junk. So, but you have a good point. We probably should encrypt the data on a mobile device as well. So we'll do it.
It was really more of a question as to whether it was, and then what are your thoughts? How are you planning on building infrastructure to do that? Since Gears doesn't seem like it has it been built. Are you planning on building something? Are you waiting for them to kind of move forward with encryption? What is it? And this is sort of directed at both of you in terms of how you protect your data on disk.
Yeah, that's a good question. I mean, part of the challenge there is, as I mentioned briefly, we use the backend to generate the encryption for the username and password. I am still not clear on how Gears, even if Gears had encryption support, essentially it would also have decryption support, and then you would need to have some kind of passphrases which the users needs to enter every time something gets encrypted or decrypted, because otherwise the hacker could just encrypt or decrypt it at random.
And is that the same sort of problem that you run into doing offline as well?
Yes.
Thank you.
Hi, Rajan. A really common question I hear is how to do synchronization, and you've had to address that. Do you mind talking a little bit more about your synchronization model?
Yeah, in our case, on the back end, we have an engine that primarily is used for versioning and comparing different versions. And we use the same engine. When you're trying to go offline or when you are going offline, it basically uses that engine to see if there is any difference between the offline content and the online content. And based on that, it is first saved as a different version. And from then on, at this point, we need a user intervention to make sure that he merges those changes. I mean, that is the case, especially when two users are offline and they work on the same document at the same time and they synchronize it. So that has to be done manually, but the rest is automated.
Yes, it's kind of tying into the other questions, but it's deeper. You say you have it on iPhone, the Gears for mobile. How did you do that? What was the approach that you used to access that?
Well, I just showed a picture of the iPhone. Mm-hmm. The iPhone doesn't have the mobile, offline support. Only Windows mobile devices have, because that's what Gears works on.
Have you thought about writing like a data URL access point? Because that's how we got apps on Safari. You can use a data URL in the WebKit. So you could have it as a basically de facto cached app in the browser. The reason I mention that is you're also looking at how you can secure the data there. You could encrypt it as a URL. You could even use OpenID access, and you could encrypt it as a URL that they have to log into to actually access even on their machine. The good thing with that is, if it isn't the right password login, say that the device gets stolen, you can have it lock out, send COM back to the main server, and delete that access point or that app on the actual browser. You could clear the temp file, clear your cache, and that'd be a way of expiring that security-wise on there without having to write software for that.
So yeah, I mean, for the iPhone, we haven't actually done anything because there were rumors that iPhone was going to come up with a new version, which would implement parts of the HTML5 specs, and that's what they have done. Right. Right.
But you get the performance of an actual server web app with some software features in it. It's kind of nice. So check it out. It's on the blog for Safari WebKit.
Thanks.
In our case, I mean, if Google Gears works on an iPhone or Safari on iPhone, yeah.
So this is a question for Raju. You talked about how you didn't have to make any changes to Google Gears, and yet you went on and talked about your challenges, like having rich functionality offline, et cetera. Have you talked to Google about perhaps incorporating within Gears the ability to sense what the hardware client has as a capability so that you can use that in your offline mode?
Well, I guess some of the rich functionalities, again, are independent from Google Gears because, I mean, each application is different and each application has a set of requirements. For example, we do some stuff like pivoting or macros. We execute macros and we have a separate engine at the back end, and which are using probably 32 gigabits of RAM, and it simply doesn't make sense to execute that in a mobile phone. So there are a few things that we don't plan to bring them offline. It will be a real challenge because there are hundreds of servers working for, in some cases, each request. So some of the applications will not be, or some of the features in those applications will not be available offline. So, but there are some requests to Google Gears team on supporting the generic functionality. For example, synchronizing is one such thing where it makes sense to synchronize your data from your offline mode to online mode, and that can be used across all applications. Maybe a common framework will be useful if Google can provide that. Yeah, we did request that feature.
So the limitation, in other words, was within Gears, not necessarily in the design.
Yes.
That's what I was trying to figure out, was which one was
It's not necessarily a Google Gears limitation. It's something to do with the design of the online application. It's not. That's the advantage of when your application is online, but then you have the challenge in the offline mode.
Thank you.
How do you really decide the memory that will be occupied on the client side for storing the documents, say, for example?
So we basically we let the user decide how many documents he has to download. By default, we have the latest 10 documents, and the documents we download are decided based on the sort order the user prefers. So in the online version, the user can choose what are the sort order of the documents. It could be the recent documents, it could be alphabetical, and based on that order, we download them offline. And especially for mobile Gears, we download very limited set of documents. In this case, I guess it's around 5 or 6 recent documents. Of course, you can change it, but then we want to keep it low, especially in the mobile version. Okay, thank you all.
Thank you very much.